Aislynn Connell is from Pikes Peak Community College, and she will be attending CU Boulder this fall in astrophysics.
All right, hi, my name is Aislynn Connell, and this summer I worked with Toby, Minear, Kristy, Tiampo, and Mike Willis, and I was studying the accumulation of sediment in Paonia Reservoir and how that affected the total storage capacity. Next slide. So sediment that becomes trapped in reservoirs depletes the total storage capacity, which over time eliminates any flood control benefits. And sediment trapped in these systems is harmful to the reservoir itself, as well as upstream and downstream stretches. And in the reservoir, dam machinery is diminished with an influx of sediment, which is often costly and hard to maintain. A surge in sediment upstream can have harmful effects like flooding and waterlogging, while the absence of sediment downstream can cause bank failure and abrasion. And as the population increases, our demand for fresh water from storage reservoirs does as well. Next slide. So for my research, I used the water data that was collected from USGS at 3 sites surrounding Paonia Reservoir. And these 3 sites were Muddy Creek, Anthracite Creek, which is a tributary, and the North Fork Gunnison Gauge, which is directly downstream from Paonia Reservoir. From Muddy Creek and Anthracite Creek, I observed the suspended sediment discharge and the instantaneous discharge, while from the Gunnison Creek, I only observed the daily discharge. Next slide. So the first thing I did was obtain a KNZ file of my site location. And with this, I downloaded a shapefile from Google Earth, as well as a hydrography data set from USGS. And both of these were put into QGIS to observe the tributaries and watershed. And I then obtained 3 DEMs or 3 digital elevation models, DEMs for June, July, and October of 2020. And I viewed the elevation difference of the 3 in QGIS. And lastly, I used a Google Earth Engine code showing the amount of water present in the reservoir for different times throughout the year. Next slide. So with the USGS Muddy Creek data, the suspended sediment discharge and the discharge of bed load were plotted. And we can see that the suspended sediment discharge is more sporadic than the discharge of bed load. And this is because the suspended sediment is the middle layer of sediment in a creek, and the bed load is the lowest layer, which requires a stronger current or velocity to move. And then I used the historical Gunnison data, and I calculated the percent of the reservoir that is full of sediment. So I first calculated the accumulation, and then I found the maximum accumulation and used that value with the original reservoir capacity to find that the reservoir is 45.45% full. And next slide. I then used Google Earth Engine to view the NDWI imagery for November of 2019 and April and June of 2020. And I compared these water levels with a USGS storage capacity graph. And we can see that in November, the storage capacity is the lowest. And this shows in both of the graph and the imagery. And lastly, we didn't find any significant results from the DEMs because of their uncertainty for water height data. The DEMs alone are not very reliable for water measurements, but they can be used with other resources. Next slide. So that leads me into future work I would like to see. Conducting water surface edge extractions on Google Earth Engine would allow me to use the DEMs as a comparison for elevation change. And I could then observe the water height surface levels over time in more depth. And I would also like to calculate the percent of sediment again after finding the percent error, because the 45.45% that I found this summer is if all the sediment were being trapped, and it doesn't account for any sediment going through the system. And with the more accurate percent, I could calculate an estimated remaining time for the reservoir if the sediment accumulation growth was consistent. And lastly, I would like to take a long-term average of all of the available data and apply any trends to similar, less studied dams and reservoirs. Just with a lack of recorded data for many dams all over the United States, having knowledge on patterns will be cost efficient as these results can be projected elsewhere and beneficial for the preservation of these systems. Next slide. Any questions?
Excellent job.
I have a question. Aislynn, if our dams are all filled up with sediment, what implication does that have in the event of high extreme flooding events like we've been seeing this year as a result of climate change?
I believe we would see a lot more flooding, and we wouldn't have any of the flood control benefits that the reservoirs offer if they are just being filled with sediment.
Thank you. That's kind of terrifying.
Okay, we have another question for you. Based on your research, do you think that sediment accumulation generally means that dams are a bad idea?
I don't think dams are a bad idea. They are beneficial, but finding any cost-effective solutions for maintaining sediment is really hard. But the solution is not to build more dams, because this is just a problem that'll keep happening. So we need to turn our attention more towards more efficient solutions.
Okay, great. Thank you so much. Are there any other questions out there for Aislynn? Okay, we will go ahead and move on to our next speaker.